Welcome to the Explainer. Today, we've got a highly technical, developer-focused topic that is going to be absolutely crucial for those of you working in security research or penetration testing. We're looking at a brilliant open-source Python tool designed to completely save your disrupted AI coding sessions. So let's jump right in. Picture this. You are deep into an authorized penetration testing task, perfectly in the zone, and you ask your AI assistant to generate a payload. Suddenly, the AI outright refuses. What happens to your workflow? It hits a total brick wall. This is a massive frustration for security researchers and developers. When you're testing authorized payloads, an AI refusal doesn't just give you a no, it actively breaks your ongoing session and completely derails your train of thought.
Here's a quick look at our roadmap today. Number 1, the broken session problem. Number 2, meet the session patcher. 3, post hoc session cleaning. 4, preventative CTF prompt injection. 5, CLI versus Web UI. And finally, 6, limitations and ethical scope.
Section 1, the broken session problem, when AI says no.
So why is this such a headache? Well, a broken session happens because tools like Codex CLI store your sessions as JSON-L files. The moment the model refuses a request, that refusal is permanently written into the session history. If you try to resume, the model picks that history right back up, and that previous refusal literally poisons its subsequent behavior. The major technical hurdle here is that you can't just open a text editor and hit delete on that line. Doing so corrupts the whole conversation structure of the JSON-L or SQLite file. Historically, your only options were to either abandon the session entirely or bust out a hex editor and meticulously fix it to preserve the formatting. It's a severe disruption, especially if you're competing in fast-paced capture the flag or CTF environments.
Section 2. Meet the session-patcher, the dual-layered solution.
Enter the solution. The Codex Session-Patcher, created by developer RiFineZ. It's a lightweight Python script that has caught fire recently, boasting over 1.4K stars on GitHub. This tool was built specifically for this exact niche workflow. It automates the incredibly tedious process of repairing these files, meaning you can get right back to your research without missing a beat.
You can really think of this tool as offering a dual-layered solution. On the left side, we have what I like to call surgery, the session cleaning feature. This is the post-hoc repair of existing JSON-L or SQLite sessions where a refusal has already messed things up. On the right side, we have preventative medicine, the CTF prompt injection. This operates entirely at the configuration layer, injecting system context before you even start typing, aiming to stop refusals from happening in the first place.
And I have to geek out for a second over how adaptable this tool is across different environments. For Codex CLI, which uses JSON-L, it injects via profile and global settings. For Claude Code, also using JSON-L, it spins up a dedicated workspace. And for OpenCode, which actually uses SQLite instead, it also utilizes a dedicated workspace. The patcher seamlessly and elegantly handles both JSON-L and SQLite formats automatically across all these different CLI agents.
Section 3, post hoc session cleaning, the surgical fix.
Okay, so refusal happens. What exactly does the tool do? First, it detects the refusal using a super smart two-tier matching strategy. It combines a strong phrase full-text match with a weak keyword prefix match, which keeps the false positive rate really low. Step 2 is an absolute lifesaver. It automatically backs up your session before it touches anything. You get one-click restores so your work is always safe. Step 3 replaces the refusal entirely. It can swap it with a simple static string or, and this is way cooler, it can call out to a language model to generate a context-aware replacement so your conversation keeps flowing naturally. Finally, it can erase those extended reasoning or thinking blocks, literally wiping the AI's internal refusal logic completely from the record.
Now, for the security-minded operators tuning into this explainer, I know you don't just trust scripts blindly. And you don't have to. You can use the dry run and show content flags. This gives you beautiful, visual side-by-side diffs of exactly what the tool intends to change, letting you preview everything safely before it modifies a single byte of your actual session files.
Section 4, preventative CTF prompt injection, stopping refusals early.
Let's look at how this preventative medicine builds into the Codex CLI. The patcher cleverly takes advantage of Codex's native profile mechanics by installing a dedicated CTF profile. What this means is the injected system context is only active when you specifically launch the CLI using the codex-p CTF command. Your regular, everyday coding sessions, they remain completely isolated and 100% unaffected.
Now, for Claude Code and OpenCode, the approach is slightly different but just as effective.
The tool creates dedicated, isolated workspaces right on your machine. For Claude, it injects instructions using a project-level markdown file in a dedicated .claude CTF workspace. For OpenCode, it does the exact same thing using an agent's markdown file. Because the instructions are scoped to these specific project folders, your default environments stay absolutely pristine. There's also this truly fantastic feature for active mitigation. If you connect the patcher to an external API, say OpenAI, a local Alma instance, or OpenRouter, you can use the rewrite flag. Before you even send your prompt to the primary AI, this feature uses your external LLM and your injected CTF system prompt to rewrite your request on the fly. It basically massages your language to make it far more acceptable to the AI's built-in guidelines.
Section 5. CLI versus Web UI. Choose your interface. You actually have two distinct ways to interact with the session patcher. On the one hand, you have the CLI mode. This is bare metal efficiency, zero extra dependencies, highly scriptable for automation, and perfect for terminal power users who just want to run a quick command and move on. But on the other hand, the tool also ships with a local web UI running on port 8080. It's a rich view front end where you can manage your session lists, view those side-by-side diffs visually, edit your prompt templates directly, and even toggle between English and Chinese.
And the best part? You don't have to pick just one workflow. Both the CLI and the web UI sync perfectly because they read from the exact same shared configuration file. So you can easily configure your templates in the beautiful web UI and then seamlessly execute the actual cleaning right from your terminal.
Section 6. Limitations and ethical scope. Boundaries of the tool.
Let's rapidly fire through some caveats to keep expectations grounded. First, the refusal detection is heuristic, meaning it might miss brand new phrasing or throw the occasional false positive. Second, to get those smooth, context-aware AI rewrites, you do need to configure and pay for external API access. Third, and this is absolutely critical, this is a workflow optimizer, not a magic wand. It cannot bypass hard, model-level safety filters for requests explicitly blocked by the provider. And lastly, because OpenCode lacks native profile system, you've got to remember to launch it strictly from within that dedicated workspace directory for the injection to actually work.
The original source material makes a vital point regarding responsibility that we need to highlight. The tool's CTF/pentest framing applies to authorized security testing contexts. Using this tool outside of authorized, legal contexts shifts the responsibility entirely onto you, the operator. We're here to break down the technology, but how it gets applied is entirely in your hands. Which leaves us with a pretty massive question to chew on. As AI assistants become so deeply integrated into developer environments, how is the industry going to balance these hard-coded safety filters with the legitimate, urgent need for authorized security testing? It's a major friction point that tools like the Session Patcher are currently bridging, but it really points to a much larger, ongoing conversation about the future of AI in cybersecurity. Thank you so much for joining me for this explainer. Keep learning, keep building, and I'll see you next time.